There is a theorem. In this theorem, the relation of conjugacy is an equivalence relation. In order to prove that the relation of conjugacy is an equivalence relation, then in order to prove equivalence relations, we need three things. We have to prove three things. What? The first, we will prove that symmetric, and the second is the first is reflexive property, symmetric property, and transitive property. Okay, and if these three properties will satisfy, then we say that the relations that we will define, okay, is an equivalence relations. So here we are taking conjugacy, the relation of conjugacy. Okay, and here let R is the relation of conjugacy. If R is the relation of conjugacy, then we will prove that this relation is reflexive, this relation is symmetric, and it is transitive. Then we will say that this relation of conjugacy is an equivalence relation. Okay, the first one is we have to prove it is reflexive. R is reflexive. Okay, as we know that E can be written as just like we can write E is equal to E and E inverse. Okay, in case of conjugacy relations, E can be written as E is equal to or we can write it is G and G inverse, just like E can be written as G, E and G inverse. Also we can write A just like A is equal to E and A and E inverse. So what does it mean by? Okay, and this implies A is related with A. Okay, A is related with A, and the second is, it is R is symmetric. So let A is related with B. Okay, we will prove that B is related with A. Then it means that A G inverse is equal to B, and here we can write A is equal to G inverse B and G inverse. So A is equal to G inverse B and G, and this implies that B is related with A. Okay, and the third is transitive property. Transitive property, and in this property, let A is related with B and B is related with C. We will prove that A is related with C. A is related to B means that B is equal to G inverse, and B is related with C means that C is equal to G inverse. Okay, and now we want to prove that A is related with C. Okay, and let me take this one over here. C is equal to GB Okay, so here you can see G, and what is B? B is equal to G inverse. G inverse. Okay, and of course, okay, yes, G inverse. So we can write it G we can write it is just like G and G inverse. So if it is G1A and this is again G1 inverse, then it means that A is related with B, B is related with C, then this implies that A is related with, or C is related with A. A is related with C. So transitive. So this relation, which is conjugacy relation, is also transitive. It is symmetric, it is reflexive. So we can say that the relation of conjugacy is an equivalence relation. So see you in the next lecture.